Well, I'm hoping you can maybe make out this scruffy sort of diagram I've done. So here's a tapered spline here. In my case, it's got like a thread nuts on the end. That's what I look for. M8, 1mm pitch, not the 1.25 which is common, 1mm. I'll put a washer up here. Then there's a plastic part which is made very tight, so that it'll mould into the splines on this shaft, and it's tapered. This is exaggerated here, I think. And then there's a washer at the bottom, which is the one at a hole in, and I cut out with a tapered reamer. It's like for cutting holes. And I kept going until it just fitted over this bottom edge here. And the idea there was to clamp this nut down, and that would squeeze this plastic part here and grip it enough, but it doesn't seem to be enough. This is a shredder part, big bolt going through here, cutting blade here. I've added this so that it's more at right angles when it tries to cut. I don't know if that's going to be any better yet. This block here, so there's some big bolts on, nuts on 22mm, I think this bolt is, which is the inside bore of this cutting blade here. This has been used, as you see, quite a bit. I've tried using belts. If you see in my other video, one problem I found with belts is that you have to have them reasonably tight, and that tries to pull over the motor in a way, and then when it does, it loosens off the belt and then it's slipping, unless you have some method of like a bracket on the other end of where the sort of pulley comes up and stops it getting pulled over, but that's more work. I had two of these on. I've took one off because I need the space down here, but this is to adjust it when I did have the belt on. Just screw that, and that pushes against there. Obviously you can slide if you loosen these nuts off. So I'm going to do a direct connection using this. I'll try a direct connection using this. This has a nut, the nut head printed out there. It's a little bit, I've deliberately made it a little bit loose, so it's got a bit of flexibility, but not too much. And when that turns, so to speak. So let you have a bit more of a look like that. So that's got a bit of a taper on. Now what I found, just a second while I move this over, get it out the way. What I found is that this plastic, this has what I call is a tapered spine connection. So it's got spines on. Can you see those there? Like almost like a very, well, like a fine cogwheel in a way, but it's also tapered. So it's not just straight. What I found is just having that on, the plastic will deform to the shape of the taper. But as soon as you come to use it, it's too soft, the plastic, that it sort of just loses the grip and turns. These are all, take my word for it. So what I'm going to try with this one, I'm going to use this is quite old, RS. Tapered reamer, 1/8 to 1/2 inch. These are very sharp blades. Well, I had a dishwasher here. and I kept, it was too tight to go in this shaft. But what I did is kept on like turning it about 4 turns, seeing how well it would fit on here. Kept doing that until it, just because of the taper of this, because of the taper of this, it might aid to the taper. It might put a bit of a taper on the cutout actually. You have a look at this, just a second. But put it on so that there was a tiny bit of teeth almost shown like this. I have used this, so it's a bit hard to show that. But this washer goes on, and we put this conversion sort of thing on. Pop a washer in the other end. Hope we've got enough space here. And we might just fit a nut on there. So I found that the washer pushes it off the thing too much to start off with. Now this will, I'm using a socket set. Does that say 14mm? And that socket there. Basically the idea there is to squeeze it to, well, when I'll put the washer back on, squeeze the 2 washers together, and those will grip this. Let's see what that looks like. Well, as I'm tightening that up, it's pushing this metal washer more onto the splines. It's not so big that goes over, it just grips the edge of the splines there, the bottom edge of the splines. Okay, I'll tighten that up a bit more, I think. I'm going to loosen it off. I'm going to put that washer on. Really would, I'll show you this actually. So that's gone a bit to the shape of that taper there. This is tapered the hole in here, by the way, to a certain extent. Can't see any spline markings on it. Put the washer on. Could do a better sized washer really. Put the nut in. No, it's not gripping with that washer on in this case because the plastic's too deep and the washer's too thick. Have a look at that washer. There's about 1.5 millimeters there. Take that washer off and it certainly grips. I might try it without that washer on actually. The washer would spread the load. Is that even screwing on? No, I don't think it is. I think it's better to use it without the handle at first. There we are. I think that's starting to tighten. I'm actually holding this because it is possible, although this is a worm gear, technically a worm gear I think, well, I know it's a worm type gear, but I don't know if there's any techniques. Normally a worm gear you can't really turn apart. It'll lock against the teeth of the worm, but on these, see, that is actually turning the motor now. If I let go of this, I'm going to tighten that very tight, as tight as I sort of dare go. Trying to show you that back end washer there. See how far that's been pushed on. But that stops it getting pushed all the way, and the widest washer there should spread the weight. There's the hope. I'm going to just try, no, I have to be careful here. I'm going to move this just a bit, just to get a bit better grip on it. No, can't really tighten that anymore. So then this does line up with the shredder. I'll show you that. Excuse me. So that just might have to rotate it a bit, obviously. We're copying this. So that just clips on, well, almost pushes on there. And we've got some adjustment forward and back on these slots. Got some adjustment, like, let's call it laterally, like this, if we need to. We haven't got any up and down, but to a certain extent that's why I've made it a little bit loose to go on this nut, big nut head. Right, I've bolt this together. I'm only going to use 2 bolts on here. I think that should be enough to hold it. I'll bolt this together, then I'll come back and we'll get wired up and see how well it does. Okay, windscreen wiper motor. Show you details. Now these are all generally different sort of fittings, so just turn it round a bit more, be careful here because it's not bolted on. And because of the direction I'm sort of coming here, I'm going to wire this up reverse polarity. As I'll show some wiring picture here. I'll go off camera, I'll get the nuts on here, washers on here and get bolted up, etc. are bolted in, it is a bit hard to get in here. By the way, have those bolts sort of down so you can slide this on top. If you're doing exactly the same model, you might redesign this so that these slots are a bit further out so it's easier to get in. The nut on here, by the way, is 8mm by 1mm pitch. 1mm pitch. Quite often you'll find 8mm by 1.25. That's quite often, like on your, if you have threaded rods on your printer. So these are 8 by 1, so it's what I would term as not a normal nut. So far as I know, normal nuts are more 8 by 125. Okay, let you have a look around that before you. Got that. Always helps if you turn the light on. Right, just see if we can turn this by hand. It's got these grips on. Oh, I won't bother. I'll get this plugged in and we'll see what happens. Get sort of lined up with a ball to catch any bits of filament, and we'll see if this jams or what have you. So put it above this bowl as I had before when I was doing the test with the belt, timing belt sort of thing, which was not too successful. As I say, I've wired this up, well, to a certain extent in reverse. I'll put a wiring diagram up here. Right, let's get, this is going off a 12 volt PSU here. Let's get started and see what's what. I'll just move in a bit closer so we can see a bit better. This ball is to catch any bits of plastic, if it works at all. Right, I'm ready to turn it on, but I'm also ready to turn it off quickly if it knacks up. A lot of noise is a fan off the PSU. Just making a clicking, bit of a clicking noise. I think it is slightly out of line. That's one reason I leave it like a bit of looseness in the nut head there. So I've got these bits that I was doing before. See a little bit of success. That's chewed off a bit of plastic, but let's try this in. This is the first test of this. Let's zoom in a little bit, but I want you to be able to see the turning thing. Let's try this thin a bit. That's gone here wire. Certainly chewed up that corner. I'll get this bit of a brim on this, I think. It's a bit of a nuisance. Right, let's try this corner here. Out of focus there. Well, it's chewed up that corner, going towards our hole. The hopper here is stopping this to a certain extent. that's chewing that thin piece up there. Right, let's try a bit thicker piece. See, this has been hacked up before with some of my other attempts. It did jam up on that thicker piece of pouring at first. Let's hold it there a few seconds. No. No, but it's jams. Not getting warm. Going to try this corner here. This is the poor quality printer, had the settings wrong. A lot of pillowing, porosity type stuff on there. So we can see that's jamming there. This wheel did seem, excuse me, this wheel did seem to turn a bit on the first time it jammed. And it's got a bit of plastic in there. But once, if I ever get this like sorted out, I'll have a reverse on this so that will loosen off. Let's turn that off. So it's certainly jamming on the thicker pieces, but as for cutting thinner pieces, I reckon that's 1mm thick, that one. Seemed to do okay. When you grab that, where's my long nose pliers at? I'll show you the ball. So this bit of plastic has got jammed in here. Yeah. Let's turn that, see if it'll turn yet. Put that in the bowl. I'll show you the bowl now. See what it's caught. I should have, oh yeah, quite a bit. But that motor is still not really powerful enough to cut the thicker bits of plastic, as you've seen, right on that thin piece. Right, I'm going to try this, which has like a thinner wall on it. Also going to try this a bit thicker. That's probably printed at 80%, that infill there. So we'll go. Turned on. Let's try the thinner piece first, which I think is going to be, I have to be obviously very careful because we have got cutting blades here. No, this is slipping here. Try and show you, just trying to get the camera. So if you watch this washer that's squeezing against this plastic, hopefully you'll see that that is slipping. What have I done with that? Right, here it is here. So can you see that turning there? So the grip between this and this is still not enough, even though I tighten that nut up as much as I can. I wonder if it's actually going against the edge of the thing. But as you can see, that is turning there, but it's not turning this. It's acting a bit like a clutch. They call it a safety clutch. Very slightly, well, slightly what we call lukewarm. Right, obviously that's what we have to call another fail. One of the big problems here is that this spline dark that I have on these windscreen wiper motors is going to be problematic. It's very hard to connect that to any plastic bits without maybe drilling a hole through the shaft or something to give it maybe more like grip. So I'm going to work on another method of powering this, and that'll be in a separate video. I was classed as that as a, what we call it, a semi-success, a small success. There's a bit of plastic I ripped off the edge. And this bowl was empty. Quite granular. Like, as you can see, I've took it off, and you'll see there's bits of plastic. See, there's especially very fine bits here. So it's been chewing this up, and this has been slipping. I'll take this off and show you the part. You can see there that has been pressing. It's like left an indent there where it's been pressing. You see some shavings there that have been stripped off. Can I pull this off? Yep. And that spline there. Where am I? So it's just chewing up the plastic here. One problem with these like tapered spline is that, I think, and it's always going to be that they should actually drill a hole through here. No, somehow a hole through here, which I don't want to do. There's a look. Can we see inside them? So this has just been totally slipping there. It's not gripping enough, even though that nut has been indenting the plastic there. Right. Now these have a great deal of torque because the motors are quite powerful, 12 volt, and the worm gear has a lot of like reduction in the gearing. Right, different motor, different video. In my case, I wired it up with positive on there and negative on there. You just swap the wires over for the direction on this motor. Anyway, you have to watch, some of these wiper motors do have cams in which might catch. Okay, bit of a fail there, but some sort of success, semi-success. Chewed up that thin piece quite well.